Hey guys, today we're going to continue our previous discussion on rational exponents just by doing a brief overview of how to simplify expressions with rational exponents, and we're going to go into solving quadratic equations. We've learned how to solve quadratic equations by factoring, but now we're going to learn a different method of solving quadratics. To simplify each of these following, I'm going to first write it in terms of a radical and then simplify the radicals completely. To rewrite this first as a radical, that fraction in the exponent means I write a radical symbol and the denominator becomes the index. Inside the radical, I have 64 raised to the power of the numerator. Those two stay together. Or another way that I've showed you how to do it is to put that exponent on the outside of the radical completely. This makes it much easier than squaring that 64 and having a very large number inside. It's much more simple to find the cubed root and then square it at the end. For the 27, again, that denominator becomes the index of the radical, so inside the check I have a 3, and inside the radical I have 27 to the second power. The numerator of the exponent stays with the 27, but again, it's going to be much easier to put that exponent on the outside of the radical completely instead of just with the 27. So taking the cubed root of 64, what I'm looking for are three numbers that multiply to 64. I can start by factoring into 16 and 4, and then continuing, I break my 16 down into 4 times 4. You may continue factoring if you want, but I found the three identical numbers that multiply to 64, so I'm going to go ahead and stop here. So what I end up with is just 4 from inside the parentheses, and that number is being squared. Plus, to the right, I'm going to find the cube root of 27 and square it. So the three numbers that multiply to get 27 would be 3, 3, and 3. When I multiply those three together, I do get 27, so I can make this group and take out a 3. So now I have 4 squared, which is 16, plus 3 squared, which is 9, and adding these together, I get 25. So all of this simplifies down to 25. Go ahead and pause the video and try those next two on your own. The first should simplify down to just 10, and the second to 37. Now we're going to go into solving quadratic equations. Because these are quadratic equations with linear terms, and that term linear is referring to a variable that has an exponent of 1. So they're quadratic equations because they have exponents of 2 on the variables, and the linear term of the quadratic is the term that has an exponent of 1. Since they have both the squared term and the term that's being raised to the first power, we must factor to solve them. So to factor this first one, I need a 0 on one side, so I add the 12. I end up with 2n squared plus 14n plus 12 equals 0. I start factoring by taking out the greatest common factor, which is 2, leaving me with n squared plus 7n plus 6. And that still equals 0. I then use my diamond on this trinomial inside. On the top of the diamond, I have a 6. On the bottom, I have a 7. My two numbers are 6 and 1. So I rewrite my 7n as 6n plus 1n. I still have a plus 6 behind and an n squared in front. I'm going to bring that 2 down later, so I'm just going to leave it alone for now. On the left, I take out an n, leaving me with n plus 6. On the right, the only thing I can take out is a positive 1, leaving me with n plus 6. Now, since those n plus 6's match, I may factor those out, and my second parentheses is an n plus 1. All this is equal to 0, and again, I cannot forget to bring that 2 down. Now, to solve completely, I need to take every factor that has an n, so that would be this n plus 6 and the n plus 1. And I'm going to set them individually equal to 0 and solve each of these equations. So I have n plus 6 equals 0, n plus 1 equals 0. So this gives me n is negative 6 or n is negative 1. So I have two solutions. N may be negative 6 or negative 1. Go ahead and try that next one on your own after pausing the video. You should get two answers of 5 and -1. From here, we're going to go into solving quadratics that have no linear term. So if you notice in this equation, there is an x squared, but there is no just x term. So the main idea here is that we are going to isolate the variable and then square root both sides to clear the exponent. So I have x squared. If I square root that, if I put a radical with an index of 2 over it, what happens is these undo each other and leave me with just an x. But I have to do the same thing on the right-hand side. The square root of 9 is 3. So we find that x equals 3. However, I want you to think about this. If I take 3, going back to check my answer, if I take 3 and square it, I get 9. But also, if I take -3 and square it, -3 times -3 is +9 as well. So there are two answers when I only came up with one. The reason for this is that we put in a radical. This radical was not here until we put it in. Because of that, anytime you put in a radical, you must put in a plus or a minus sign. This signifies that your answer may be either +3 or -3. So here's your note. Anytime you insert a square root, you must also insert a plus minus. This symbol simply shortens the plus or minus. So what this means is that x may be +3 or x may be -3. Down here, I see n squared. It's already isolated, so I'm going to square root both sides to get rid of that exponent. But I just put in a radical, so I must also put in a +negative on the right-hand side in front of that 25. The radical and the exponent cancel each other out, leaving me with just an n on the left. And the square root of 25 is 5, and it's positive or -5. So n may equal 5, or n may equal -5. To the right, I'm going to go ahead and square root both sides to get rid of that exponent. Since I square rooted, I put that radical in, I must also put in the positive or negative signs. On the left, the radical and the exponent cancel each other out, leaving me with just b. And that equals the positive or negative square root of 81, which is 9. So my two solutions are that b may equal 9 or b may equal -9. Go ahead and pause the video and try the next two on this slide on your own. You should have from the first n equaling 8 or -8, and from the second r equals 4 or -4. We're going to advance this just a little bit more. Now we have more going on, and that exponent is not necessarily by itself. So first what we're going to do is isolate the squared term. So to isolate this squared term, I'm going to subtract 3 from both sides. When I subtract 3, I find that n squared equals 79. From here, we are going to square root both sides. Do not forget the plus or minus. So I insert a radical on the left over my n squared and on the right over my 79. Over the 79, I can't forget the plus minus. On the left, the radical and the exponent cancel, leaving me with just n, and that equals positive or negative square root of 79. 79 does not factor, so we aren't going to be able to break this down into any pairs. However, you do need to verify that you cannot simplify this any further. Since we cannot, we're simply going to say that n equals the square root of 79, or n equals the negative square root of 79. Again, make sure that your radicals are simplified completely, and this one is, so we get to stop. On the right, I add 7 to both sides to isolate my squared term. That leaves me with n squared on the left equals 29 on the right. I'm going to square root both sides to get rid of that exponent, but I'm not going to forget that plus or minus in front of the 29. So n equals either positive square root of 29 or negative square root of 29. Since I cannot simplify any further, this is the most simple form of that radical. Go ahead and pause the video and try those next two on your own. From the first, you should have positive square root of 2 or negative square root of 2. From the second, you should have positive or negative square root of 72, which simplifies to 6 rad 2. So v should equal positive 6 rad 2 or negative 6 rad 2. Again, do not forget to simplify your radicals completely. Find any pairs that you can and make sure those pairs come out of the radical. We're going to advance this just a little bit more. First, we are going to isolate the squared term. So notice in this first one, my squared term is now a whole set of parentheses. It's not just an n anymore. But looking at that thing that is being squared, it is all alone on the left side. To the right, this is not isolated on the left-hand side. So when we get to that one, we're going to have to move that 10 over. But in this first one, since it is, my next step is to square root both sides. I need to get rid of this exponent. That is the only thing on the left-hand side, so I can square root both sides. On the right, I put a plus or minus in front of my 16. And on the left, this radical and that exponent undo each other. That leaves me with just an n plus 2. I then have positive or negative, and the square root of 16 is 4. So after we've done that, we then need to continue solving. But I have two options here. I can have a positive 4 or a negative 4. So I'm going to write one equation for each of those. N plus 2 equals 4, and n plus 2 equals negative 4. Now I solve each of these to find my two solutions. Subtracting 2, I find that n equals 2. And subtracting 2 on the right, I find that n is going to equal a negative 6. So my two solutions are n is 2 and n is a negative 6. On the right, my first step is to isolate this squared term. So I am going to add 10 to both sides to get that all by itself. Now that I've added 10, my squared term is on the left all by itself. I have n plus 2 all squared equals 25. After it's all alone, I may square root both sides to get rid of that exponent. I can't forget that plus or minus. So this cancels out, leaving me with just n plus 2 on the left. And on the right, the square root of 25 is 5, so I have positive or negative 5. To solve, I need to write two equations, one for my positive 5 and one for my negative 5. Solving each of these, subtracting 2 from the left, I find that n equals 3, and from the right, I find that n equals a negative 7. Go ahead and pause the video and try those next two on your own. For the first, your two solutions should be 11 and negative 1, and for the second, you should have n is 16 and n is 0. Now on to our last slide for the day. I'm going to follow my steps and isolate my squared term by subtracting 6 from both sides. I then have n minus 2 all squared equals a negative 40. I now square root both sides to get rid of that exponent on the left. Don't forget your plus or minus in front of the 40. So on the left, I have n minus 2, and that equals positive or negative square root of negative 40. But you need to be careful. It is not possible to have the square root of a negative number. There is no way that we can have two identical numbers that multiply to a negative. So this has no solution. Anytime you have the square root of a negative, there is no solution. Please go ahead and finish this slide on your own without me, and have an awesome rest of the day.